Interpretation and diagnostics. How do we check and validate our multiple regression model? Just like simple regression, multiple regression has assumptions we must check. Remember linearity. The relationship between each predictor and y is linear. Independence. Observations don't influence each other. Normality. The residuals should follow a normal distribution. Equal variance. Residuals should have constant spread. And for multiple regression, we add one more: no perfect multicollinearity among the predictors. In multiple regression, we make several residual plots. First, plot residuals against the predicted values. A random cloud is what we want. Then plot residuals against each individual predictor. Residuals versus age look fine here, no pattern. But residuals versus BMI show a curved pattern. This tells us the relationship with BMI may be nonlinear, and we might need a quadratic term for BMI in the model. Leverage is about how unusual a point's x values are. Most of our data points cluster between x equals 2 and 8. The vertical dashed line marks the center of x. Now look at this point way out at x equals 16. It has very high leverage because its x value is far from the center. High leverage points have the potential to strongly influence the regression line, pulling it toward them. Cook's distance combines leverage and residual size into one overall influence measure for each data point. The formula looks at how much the predictions change when we remove observation. A point can be influential if it has high leverage, meaning unusual x values, or a large residual, meaning it doesn't fit the model well. When both are present, the influence is greatest. As a rule of thumb, investigate any point with Cook's d greater than 1 or greater than 4 divided by n. Let's tie it all together with a diagnostic workflow. Step 1, fit the model. Step 2, make residual plots against predicted values in each predictor. Step 3, check normality with a histogram or QQ plot of residuals. Step 4, identify outliers, points with large residuals. Step 5, check leverage for points with unusual x values. Step 6, compute Cook's distance for overall influence. If problems are found at any step, consider removing outliers, transforming variables, or changing the model. What do we do when assumptions fail? For nonlinearity, add polynomial terms or transform variables. For unequal variance, try weighted regression or transform y. For non-normality, log or square root transformations can help. For influential points, report results both with and without them. And for multicollinearity, remove or combine redundant predictors. To summarize diagnostics in multiple regression, always check the line assumptions plus multicollinearity. Make residual plots against predicted values and each predictor. Understand leverage as a measure of unusual x values. Use Cook's distance to assess overall influence. And when assumptions fail, use transformations, try different models, or at minimum report your findings transparently.